Hi, this is the second part of the physics setup. So after you have written the case file, double-click on it to open it. By now, you should make sure that in your working folder, you need to have the UDF defined in it, and the case file double shear layer, and the data file IC. These are required for the initial setup. So when you open Fluent, if the mesh is not displayed, go under Display and click on Mesh, and Display. In order to compile UDF, which is used to read in the initial velocity field for our case, go to Define, User Defined, Functions, and Compile. Click Add to find the UDF that you want to compile. In this case, it should be defined init, and select OK. Your computer needs to have a compiler in order to successfully compile the UDF. So one of the suggested compilers would be Microsoft Visual Studios, but that costs money, and if you want to get a free version, you can search Microsoft Visual Studios Express, which is a free version by Microsoft, which would also enable you to compile the UDF. So after you have the compiler installed, click Build and Load. But I have previously compiled this UDF, so I will not do it again. So after successful compilation, go to Define, User Define, Function Hooks. And beside initialization, click Edit, and then choose Define Init Velocity LIBUDF on the left-hand side, and then click OK. And then click OK again. So once all this is done, go to Solution Initialization and click Initialize. This will initialize the velocity field for this problem using the UDF. So now, when you go to Graphics and Animations, click Contour and Setup. Select Contours of Velocity, and we can choose X velocity, and Display. Now we can see the initial setup of the velocity, which is a double shear flow. We can also see the velocity components in a wide velocity, which is the perturbation we added to this field according to our Sommerfeld equations. After you check that the initial field has been set up, we need to write three cases in order to perform the three different solves for three different Stokes number flow particles. So go to File, go to Write, and write case. Here we can do double shear layer point Stokes 0.2. Okay. And then write another one called Stokes 1. Write a third called Stokes 5. After all this is done, you may close the case.